Okay. Good morning again, everyone. And so, from our previous videos, we talk about the R, the environment of R, how to have data in R, how to do descriptive statistics, and so on. And now we want to talk, this expression of normal distribution things are very important when we are in statistics, and we need to understand how, at what moment we are saying that our data is normally distributed, and how to check even this normal distribution things and so on. Then this one is video number 4, and to get rightly what we said about downloading data and the statistic, you have just to check on video 3, video 2, and then video 1. Okay. Let's say normal distribution. We will talk about it. Normally distribution data. Okay. Let me generate kind of data, which is normally distributed, and see what we are calling normal distribution data and how even to know it. Okay, normal data. Let me call it normal data and assign it like that. Okay, the command I can use here to generate normal distribution data is rnorm, and let me say 1000 observation and 15 means and 5 standard deviation. Okay, I can run as I showed you. Those important commands you have to know when you are around here is how to run. For example, you can use this one, but the control also control plus enter can run also when having your cursor just in front of your command or your program. And after it also, for how to clean your console, you can use control plus L, or maybe having this one, clicking on it, and your control can just be deleted. Okay, your console. Okay, here for example, let me run it. Okay, and here for example, what's also we are talking about assignment. When you are just taking something, a program or a command, and putting it under a name, is what we are calling an assignment. Like I use this name normal data, saying that wherever you will see normal data is representing what I put there. And I use the less sign, and now this one, okay, to have the command itself rnorm. Then I assign it to be to have the name normal data, and you can see normal data here. That is. So when you assign something to a name, the specific name, you can see when I run, I cannot see anything. So only those names in blue I can see, and so on. If I need them, maybe now to see them, I have an now to go and click on it, it will come and I will see. Click on it, it will come and I will see. Or maybe I can use command view and so on. But here, what I want to have is normal data, which are normally distributed, because I want to show you how normally distributed data look like and so on. Okay, then we have many checking. We are saying visualization checking. We can use some graphs and so on to see. And you have also numerical checking. We can use also some tests, tests like Shapiro test, Lilly test, to see if really our data is normally distributed. Let us start with those visualization. Command visualization checking. Okay, visualization checking, and we can use it in that case, for example, histogram. And now this data which you normally distribute, copy it, and I can just put it there. Yeah, and now run. Okay, can you see what it's giving us? The histogram is giving us. Okay, because this data I generate normal distributed is what is giving me. It's already normal distributed. Now, how to understand those graphs and so on? How, when you see the data, to see if it's normal distributed? Okay. Basically, I'm saying when I'm explaining this part that when you see something, what is at the left is the same thing which is at the right. Can you see I have 1, 2, 3, 1, 2, 3. But can you see what is happening is like they are not really same. Can you see the first one at the left is the same, at the right, left, right is the same here. Also here, what is the at the left is the same like the way with the one which is at the right, but the remaining ones, the big one, are not the same, but it's still normal distributed. Okay, normal distribution is not meaning that it's really everything is the same. No, but basically, as I'm just saying, when you see 1, 2, 3, what is at the left, the same things which are at the right. Okay, things like that is normal distributed. At the moment, we will be having everything same, like what is at the left is exactly what is at the right. At that moment, we are at the highest level of the normal distribution, which we are calling symmetrical distribution. Is what is happening. That one is histogram, and you can use also this one, QQ norm, to do the same thing. Yeah, QQ norm will come like that. And when we are having QQ norm to see exactly what is happening, we have also to proceed with QQ line. With QQ line now, you can now understand what is happening really. Okay, with this one now, I have another line. Yeah, okay, it's not, let me using colors and allow us now to see them very clearly. Let me use green for the data, and the red for, okay, and the red for the line. Okay, red. Okay, let me restart the running of this one. Okay, the run it's this one again. Okay, can you see what is happening? Okay, the one in green is the distribution of data, and the line is the reference. Okay, when this one which is in green is around the line, is not very far from the line, it's just following, we have also normal distribution. Okay, but if we have, for example, the data, the one in green coming up, they are going very very down, coming up, data is not normal distributed. Okay, when this one which is in green is very near to the line, we have what we are calling normal distribution. That is, and here it can be understandable in the sense that the data generated here is normal distributed data. That is another way to see how our data is distributed. Okay, those one are what we are calling visualization checking. We have also numerical visualization. Okay, like okay, let me call them numerical visualization. Okay, what is happening is sometimes from even numerical visualization, is it visualization checking, okay, numerical test, let me call them not test. What is happening is at some point when you are checking on a data, you can see that you are doubting, you don't know exactly if from the line or from the graphs you can say that is normally distributed. At that moment, you need to use numerical tests, which cannot lie because it's just numbers and you have to conclude. And we have, like what I'm just saying is here, when you are using some things very specific, or you need to download a specific package. To do those tests, I need this package called NOR-test. Okay. And here, for example, let's say I'm having already the package. I cannot install it again. And after installing, even you need to load it. Here, what I need just to do is just to load the package. The package is called NOR-test. Okay, then let me load it. I loaded it. It's okay. Then I can use Shapiro and the Lily test. Shapiro test is now this one. And let me Shapiro test, let me use my normal data. Okay, and I have here, I have the result. Shapiro will normally test. Okay, Shapiro test is saying what? Let me tell you. Our H note, wherever we are doing the normally checking, the H note is okay. H note is what? H note is the null hypothesis, which is telling us that data is normally distributed. Okay, that is the H note. Data is normally distributed. Then we have to reject or accept H note or null hypothesis. When I'm saying H note, I'm talking about what we are calling null hypothesis. Okay, then it's saying whatever the test we are doing in normal distribution like Shapiro test, Lilly test, and whatever, the null hypothesis is saying that normally data is normally distributed. It's now from the result, now you can reject or accept the result, accept the null hypothesis. Okay, the rule there, let's now make another introduction. The rule there is we are just referring ourselves to the value of p-value. In science, when p-value is less than 5%, we are rejecting H note. But when p-value is greater than 5%, at that moment, we can accept H note. Okay? Then let's say data is normally distributed. That is our H note. And now we run the test. After the test, can you see what is happening? We can see what we are just saying. We say that the H note data is normally distributed. Now let's ask the value of p-value. How is it? The value of p-value is here greater than 5%, is greater than 0.05. At this moment now, we can now fail to reject or accept the H note. Then we are making conclusions saying that really data is normally distributed because we cannot reject H note because p-value is greater than 5%. Can you see what is happening? Okay, another test you can use is what we are calling Lilly test. Okay, Lilly test also, I have just to run it like that again, and now have my result. Okay, can you see what is happening? You have here p-value slightly greater again to 5%. Okay, but can you see someone was asking me one day, okay, he was expecting to have the same values everywhere. No, according to the test, no, but we cannot have the same value of p-value, but the conclusion should be the same. If the conclusion of the first test is different from the conclusion of the second test, that means that there is some wrong thing, there is some problems. Okay, and can you see even those p-value values are different, we are making the same conclusion. Here also you can see p-value is greater than 5%, and we can now accept our H note, which is data is normally distributed. Yeah, that is done. What is very important here is the normal numerical one, because from there we are just, everyone is just saying the same thing. If we see one, everyone is just saying one. But from visualization, sometimes the ideas can be divided. Can you see someone saying that no, me, the way it is, the graph is looking, I cannot conclude that it's normal distribution. Another one can say that no, it's normal distributed. But from the numerical test, you can get them right because the data which are just talking. Okay, then we take this video to 4 to talk about normal distribution, how the normal distribution look like, how to recognize them, how to check on normal distribution. Okay, and we generated our normal distributed to check it. Let's say in our next video number 5, we will see really if you are dealing with data. Here we generated data, we are dealing with our own data, and you are doing some analysis how to check them and so on. Thank you so much for your time. Then you have to make time to just look video 5 to get more ideas about all those things and so on. Thank you so much for your time.